The final chapter that we're going to look at this year involves making use of the measurements that we just looked at in the chapter we have finished, and two measurements in particular. Okay, so even though we're dealing with a new concept called density, density relies heavily on two of the measurements that we used in the previous chapter, and those two measurements are down there on that screen: mass and volume. Now, just before we go into this chapter, let's do a very brief recap on how and what mass is. First of all, what it is, and then how it's measured, and likewise with volume. First of all, with mass, mass simply refers to how much matter is packed into you. Okay, and obviously the more matter that is packed into you, the heavier you're going to feel. So therefore mass is related to weight. Okay, mass and weight are not the same thing. Mass is related to how heavy something is, because the more I pack into something, the heavier it's going to be. You know, when you go to the supermarket and they have these cups that you can fill up with sweets, yeah, the more sweets you pack into that cup, the heavier the cup is going to be. So therefore the more you're going to pay when you get to the cash register. All right, so that's very similar way to density. The less, or to mass, the less sweets in that cup, then the lighter it would be. Okay, so therefore mass is nothing more than the amount of stuff, the amount of matter that is in something. Okay, and of course the standard unit of mass is the kilogram. Maybe remember that. And how do we measure mass? We measure mass on what we call a digital scales. Digital scales. Or if you just want to call it a mass scales, that's okay too. Okay, but the kilogram is the standard unit. It's the SI unit. And as well as that, then in the lab, usually we normally use grams. Okay, what about volume? Volume, another word for volume, is the size of the object. Okay, so volume is better known as the size of the object. And volume is measured in centimeters cubed. Because don't forget, with volume, we are really dealing with cubes. Okay, we're dealing with the amount of centimeter cubes that are in something. So the bigger something is, then the bigger its volume is going to be. Now, here's the key question. How did we measure volume? How did we measure the size of, say, a cube? Well, that was easy. Because if it was a cube, well, then all we had to do was to measure the length and the width and the height, length, width and height, and multiply the length by the width by the height. But if I asked you to get the volume of a potato, which I did ask you to do in your practicals earlier on, how would I get the volume of a potato? And the answer is, I would put it in, if it fits, to a graduated cylinder. Or I could put it into an overflow can, which would send the water into a graduated cylinder. Okay, so I just want you to recap on all of that. So mass is the amount of matter that's packed into something, so therefore it's related to weight. Measured in grams in the lab, standard unit is the kilogram, and we use the digital scales or mass scales. Volume is the size of the object, measured by calculation if it's regular, or if it's irregular, then it's measured by using a graduated cylinder if the object fits in on its own to see how much the water goes up, or else we use a displacement can or an overflow can together with the graduated cylinder to see how much water the object pushes out. Because don't forget, the volume of water pushed out is the same as the volume of the object that you have just submerged. Okay, so that's a little bit of revision coming from the previous chapter. Now, as we said already, density is dependent upon two of the measurements we met in the previous chapter, mass and volume. Okay, so therefore when you take mass and volume together, think about it. Mass is the amount of matter in there, volume is the size. So therefore density is a way of describing how the matter is packed into a certain volume. So how the mass is packed into a certain volume. And there are two ways that can happen. First of all, we've got low density. Okay, a low density object would be something that's very, very big, but has a tiny amount of matter inside it. Now, can you think of anything that is big and has a tiny amount of matter? Now, just think, if it has a small amount of matter, it's going to be very light. So think of something that is big, but light. I can think immediately of a sponge. Okay, there's a sponge. What about a sponge? It's a fairly big size, but there's a tiny amount of matter in there because most of that sponge is filled with air. Another thing I can think of is, you know, the polystyrene packaging that comes around a new television or a new washing machine, this stuff, yeah? In there, it has a big volume, but it has a very, very small amount of matter. So therefore it's going to be big, but very, very light. So I suppose when you're talking about low density, you're talking about something that is big and light. That's the most important thing. So they're big objects, but they're very, very light. And why is that the case? Because in the sponge and in the foam, what do we notice? The particles are well spread out. So there's a lot of space between the particles, meaning that it has a big size, but very little matter. Okay, what's the opposite to low density? High density. And in a high density object, we've got a situation where a small volume has a large mass. So in other words, you pack a huge amount of matter into a very small space. Now, how would I describe that? Well, high density is normally small objects that are heavy. Because if there's a lot of mass in there, they're heavy. So I want you to think for a moment, think of something that is small and heavy. And you'll think straight away of something like maybe a knife, part of your cutlery. You'll think of something like a steel ball. Okay, that'll be small, but it's going to be very, very heavy. You might have something like a brass weight. Or you might have something like, for example, a lump of gold. A lump of gold is small, it's gold. Small, but extremely heavy. And there's a lovely liquid which you have in the lab, which again, when we get back to school, I'll show you, called mercury. And mercury is a liquid, but it's a liquid metal. And the liquid metal has loads of mercury atoms packed into it, so that small little volumes have a lot of mass. And there it is there. Okay, it's a liquid metal. We do have it in the lab, and I'll show it to you when we get back. Why do the small objects have a lot of mass in there? Because, as we said down here, particles are tightly packed together. Okay, so if I was to look at 1 cube of gold, what would I notice about its particles? Well, the first thing I'd notice is that all the particles really tightly packed together. They're so tightly packed together, that means a lot of mass in there. And if there's a lot of mass in there, it's going to feel very, very heavy. So, low density, big and light. Why? Because there's a little bit of matter all spread out. High density, small, heavy. Why? Lot of matter in there, which is very, very tightly packed together. So keep those two things in your head as we move along. So just to remember some important key definitions before we get into the actual bones of this thing. There are 3 words we have to know: volume, mass, and then density. If we don't understand volume and mass, then we can't understand density, because density is the relationship between volume and mass. Okay, so what's mass? The amount of matter in an object. The more matter in an object, the heavier it's going to be. So mass is related to weight. Volume is simply the size of the object. The bigger the volume, the bigger the object. Simple as that. And lastly then, density is the amount of matter in 1 centimeter cubed of a substance. Now, again, I want you to think about what 1 centimeter cubed is. A 1 centimeter cube is a cube like this that measures 1 centimeter by 1 centimeter by 1 centimeter. So it's a cube whose length and width and height are 1 centimeter each. But notice that density is the amount of matter in 1 centimeter cube of a substance. Now, why is that the case? Well, in science, it's extremely important to be, number 1, accurate, as we had in the previous chapter. But number 2, it's important to be fair. We've got to be very, very fair. Okay? If I said to you, which is heavier, a bag of coal or a pillow of feathers? Now, that's not very fair, okay? Because you're dealing with a bag of coal, which has a lot of matter in there, and then a pillow of feathers, which has very little matter. So what we've got to do is we've got to take the same quantity of both. And then we ask ourselves, what's heavier, 1 centimeter cubed of feathers or 1 centimeter cube of coal? Obviously, 1 centimeter cubed of coal is going to be heavier, so therefore we would say that coal is more dense than feathers. In other words, there's more matter packed into 1 centimeter cubed of coal than there would be into 1 centimeter cubed of feathers. Okay, so it's very important that we standardize. That's the key word, that we standardize the volume. You can't just take different volumes. You can't say which has the greater density, a small cup of tea or a big cup of tea. That's very unfair. All right, talk about big cups of tea. I like big cups. See, I like big cups. So therefore, if my friend had a small cup and I had a big cup, and we said, who has the greater density here? No, can't do that. You've got to bring them down to the same volume. So therefore, density is the amount of matter that is packed into 1 centimeter cubed of any substance. The more matter in 1 centimeter cubed, the heavier it's going to feel, and therefore the more dense it's going to be. Okay, so how do I work out this density thing? If density is the relationship between mass and volume, how do mass and volume work together to give me density? And the answer is this. To get the density of any substance, we need to know the mass in grams or kilograms, and we need to know the volume in centimeters cubed. And then what we do is we simply divide the mass by the volume. And that is the formula that you need to remember for density. So you say it to yourself 10 times, density is mass over volume, density is mass over volume, and you keep on saying it until you never forget it, okay? So the density of an object is mass over volume. But here's the key thing. Mass is in grams and volume is in centimeters cubed. What's density in? Well, the answer is, because density is the relationship between two quantities, then the symbols of the two quantities have to be in the density measurement. So in other words, if density is mass over volume, and mass is grams and volume is centimeters cubed, then density is equal to grams per centimeter cubed. And don't ever forget to put your units down after density, because density doesn't make any sense unless you tell me that it's in grams per centimeter cubed. Okay, so keep that in mind. Okay, let's get rid of that and go through the slides. So, to measure the density of any substance, we need to know its mass, preferably in grams, and its volume, preferably in centimeters cubed. Now, it doesn't have to be. You could have kilograms and you could have meters cubed, or you could have milligrams and you might have millimeters cubed. But the key thing normally in the lab is that the mass is in grams and that volume is in centimeters cubed. Whoops, centimeters cubed. Okay, that's the norm. That's what we normally work with when we're dealing with laboratory measurements. Okay. Whoops, a daisy. Let's try that again. Go back to black. Oh, it's not really mine to take my thing off. No. Anyway, okay. So mass is in grams and volume is in centimeters cubed. So there's the formula. The density of an object is the mass of the object divided by the volume. And as we said already, hopefully mass is going to be in grams and hopefully volume is going to be in centimeters cubed. And if that's the case, then density itself will use both of these together as grams per centimeter cubed. So D equals M grams V centimeters cubed, which means density equals grams per centimeter cubed. And I want you not to forget that. So density is mass over volume. Mass is grams, volume is centimeters cubed, so density is grams per centimeter cubed. Now, we're going to do a little bit of practice, okay? And I want you to practice these. What is the density of a piece of wood of volume 40 centimeters cubed and mass 16? Now, as soon as you read that, what do you notice? Density, and it has a formula. Density is equal to mass over volume. Now, just keep that in mind. That's your formula, okay? So all you've got to do now is fill in the mass on top. The mass is 16 grams, and the volume is 40 centimeters cubed. And then, of course, I wouldn't expect you to do that in your head, but you reach across to your calculator and you divide 16 by 40 and you'll get 0.4. Now, what are the units? Well, grams on top, centimeters cubed on the bottom, so it's grams per centimeter cubed. Okay, so keep that in mind. What is the density of a piece of wood of volume 40 centimeters cubed and mass 16 grams? Write down the formula first, and please always write down the formula. Okay, always write down the formula before you use it. And that, in physics, that's the most important thing to do. Show me and show the examiner that you know the formula before you go and fill the formula in, because you'll always get marks for just writing down the formula, and then when you fill it in you get more marks. So always write down the formula before you use it. Okay, so we have it there. Oh, excuse me, we have it there. Eraser. Oh no, you went at all. Just put a kibosh and everything for me. Anyway, okay. To find the density, we use the formula density is mass over volume. We've done that already. It's 0.4 grams per centimetre cubed. And excuse me for that horrible mess, but I don't know why it's not working. The units of density, let's see, maybe it's this pen here. The units of density are always the same as the quantity as a mass and volume as used in the question. Okay, not going to let me work, unfortunately. There we go. Okay, got it back. Now, so let's go through that again because I just distracted you all. What's the density of a piece of wood of volume 40 centimeters cubed and mass 16 grams? Well, to find the density, we use the formula. And you must always, always please write the formula down before you use it. Then you put the 16 grams in for the mass, you put the 40 centimeters cubed in for the volume, and what do you get? 16 grams over 40 centimeters cubed, which gives 0.4 grams per centimeter cubed. So you do the maths first, you divide your 16 by 40, get the number, and then put the units top followed by bottom. Grams followed by centimeters cubed on the bottom. And as it says there, the units of density are always the same as the quantities of mass and volume used in the question. Okay. Now, using that formula, I'm going to leave this slide for you to work on. I want you to work out the density of the following substances, and then when you've got their densities, I want you to arrange them in order of increasing density. Which one has the smallest density, which one has the next biggest density, and so on up to the one that has the biggest density. Okay, so you're going to take them, aluminium, mercury, copper, carbon, tetrachloride, sulfuric acid, lead, iron and silver, with their masses and their volumes, and using your calculator, you're going to write down what the densities are. Now let me do one of them for you. I'm going to do this one here. Okay, carbon tetrachloride. It has a mass of 357.75 grams. It has a volume of 225 centimeters cubed. If density is mass over volume, that means it's going to be 357.75 grams divided by 225 centimeters cubed. Now, what's that? Let's get my trusty calculator. So we got 357.75 to be divided by 225, which comes out as 1.59. Now be careful. 1.59 what? Grams per centimeter cubed. Okay, so I'm going to let you do the rest of those. Okay, let's fire up. Let's move on. Now, once we're happy with the density formula, we can do the following. Push it a little bit. Okay, try this. A block of lead has dimensions of 4.5 centimeters by 5.2 centimeters by 6 centimeters. The block weighs or has a mass of 1,587 grams. From this information, calculate the density of lead. Now, what's the key word? What do we ask to calculate? Calculate the density. Well, we do know density equals mass over volume. Do I have mass? Yes, mass is related to how heavy the object feels. So there's the mass, 1,587 grams. But do I have a volume? No. But what am I told? The block has dimensions 4.5 by 5 by 6. So in other words, we're being given a block of lead, something like this. And we're told that it's 4.5 multiplied by 5.2 by 6 centimeters. Centimeters and centimeters. Now, if you go back to the previous chapter, if I want to work out the volume of that block, I have to multiply the length by the width by the height. So the volume is length by width by height. So therefore I take the three numbers, I take the 4.5, I multiply it by the 5.2, and then I multiply it by 6, and I get 140.4 centimeters cubed. Previous chapter. Centimeters cubed. Volume is always in units cubed. So now I've got the volume. So I had to do a little bit of work to get the volume, but now I know what the volume is. I put that down here. 140.4 centimeters cubed. And using those, what do I end up with? Well, 1587 divided by 140.4 equals, and the answer comes out as 11.3 what? Grams per centimeter cubed. So that's what lead is. There's your density of lead. So sometimes in these questions you might also be asked to do a little bit of work on the volume before you can find the density. So that's why the previous chapter was so important. And if you're not too sure how to work out your volumes, go back to the previous chapter, look at the slides, go through the slides again and make sure you understand how to calculate your volume. Okay, what about this one? 28.5 grams of iron shot. Now, iron shot is basically tiny little spheres of iron that they use in a rifle, okay? Is added to a graduated cylinder containing 45.5 centimeters cubed of water. The water level rises to the 49.1 centimeter mark. So from this information, calculate the density of iron. Now again, what are we being asked to do? We're being asked to calculate the density. So you write down the formula. Density is mass over volume. Now we still have the mass. The mass is related to the weight, 28.5. So 28.5 grams, that goes on top. And then the volume. Again, we're not given the volume directly. What are we told here? We're told that the iron is added to a graduated cylinder. Okay, let's take a look at that. So here's your graduated cylinder, like that, or something like that. And what happens? The water is already up to 45.5 centimeters cubed. But when you put the iron in down here at the bottom, the water rises. And the water rises up to 49.1 centimeters cubed. Now, I hope you remember from the previous chapter that the rise in water is equal to the volume of the object that caused that rise. So if the water goes from 45.5 to 49.1, 49.1 minus 45.5, that's a rise of 3.6 centimeters cubed. So therefore, that 3.6 centimeters cubed must be the volume of the iron, because it's the iron that was added to the graduated cylinder, pushing the water up by 3.6 centimeters cubed. So therefore, 3.6 centimeters cubed must be the volume. And again, we take the 28.5 as the mass in grams, divided by the 3.6 centimeters cubed, which is going to give me the density. So 28.5 divided by 3.6, and that comes out as 7.92. Now 7.92 what? Grams per centimeter cubed. Please always put your units in when you're finished. So again, there's another way that the question has asked you to work out the volume before you could get the density. So the previous chapter, very, very important. Okay, so following on from that, let's just see this density triangle. When we have one formula representing density, density equals mass over volume, okay? And if density is mass over volume, watch, density equals mass over volume. There's a triangle in there. See that? A triangle. Now, if I did that a little bit better, look where the letters would be. The D would be in the bottom left, the V in the bottom right, and the M at the top. Okay? The line is like that, and then we put a little multiplication sign in here like this. Now, what does that little triangle tell me? Well, that triangle contains three formulas. Or formulae, if you want to be very, very scientific about it. And here's the three formula. First of all, what's the formula for density? Now, say you forget, but say you remember your triangle, okay? The formula for density is the formula that you get when you look at the triangle and take density out of it. What's left? Mass divided by volume. See that? So therefore, density is mass divided by volume. That's formula number one. Okay, let's put density back in there. Now, here's formula number two. Say somebody asked you to get the mass of an object. What's the mass equal to? Well, here's what we do. Let's take mass out. What are we left with? We're left with density by volume. See that? And lastly, what's the third one? Let's put mass back in again. Well, volume. What's volume equal to? Well, let's go back to the triangle and let's take out volume, because that's what we're looking for. And look what's left. Mass over density. Aha. So in other words, in my formula triangle, there are three formulas. So the way I normally do it is I always cover up the letter I'm looking for. So if I was looking for density, I would cover up density like that with my thumb, and I'd say, oh, density equals mass over volume. Okay. Let's just get rid of that and put it in properly. density. If I wanted volume, what would I do? Well, I'd put my thumb under volume like this, and I'd say, okay, volume equals mass over density. Good. And lastly, if I wanted to get mass, well then what would I do? Well, I'd put my thumb over mass like that, so I couldn't see it, and I'd write down mass equals density over volume. So the triangle is super helpful to us when we want to get the three formulas that are involved in density. So the first one that you have to know off by heart, density equals mass over volume. See the triangle? Density equals mass over volume. So you draw your triangle, density, mass, and volume. You put a line between the mass and the volume, so a line across the middle, and a multiplication sign then between the density and the volume. So let's take a look. The density formula can be placed in a formula triangle as follows. So there it is. That stands for mass, that stands for density, that stands for volume. Okay, and the triangle is a very nice way for me to work out the three formulas. What's density? Well, first of all, put your thumb over density. Density is mass over volume. What's volume? Put your thumb over volume. It's mass over density. What's mass? Put your thumb over mass. It's density by volume. So the three formulas again, density is mass over volume. Volume is mass over density. And mass is density by volume. You can't ask for anything else. That's it. They're the only three formulas they can ask you in terms of density. Okay? So we have the one that we already know, density equals mass over volume, and then they are the other two, which you already had up there, those three. So we're going to try and follow that into the next couple of examples. So let's take this one here. What is the mass of the ethyl alcohol? Now don't worry about the chemicals or anything else that's used here. If you don't understand there, it doesn't matter. We're dealing with density. So what is the mass of the ethyl alcohol that exactly fills a 200 centimeter cube container? The density of alcohol is 0.789 grams per centimeter cubed. Now, again, ask yourself a question. What are you being asked to calculate? And the answer is, what is the mass? So I'm being asked to calculate mass. So you draw your little triangle like this. Density equals mass over volume. And you put a little multiplication sign in there. Okay. Now, what am I being asked for? I'm being asked for the mass. So you put your thumb over mass, and you'd say mass from the triangle equals what? Density by volume. So now, let's look for density. There's density there. Put that in, 0.789 multiplied by the volume, 200. So, 0.789 multiplied by 200 comes out as 157.8. Now, 0.8 what? Elephants, pavlovas, cups of tea, what is it? What are the units? Well, we're being asked for mass. So therefore, go back to density. What's in the density units? Oh, look, there's grams in the density units. So my mass must also be in grams. Okay, so that's how you would do a question if you were asked about some other quantity except and given the density. Okay, let's take one more. Let's take the bottom one here. What volume of silver metal will weigh exactly 2,500 grams when the density of silver is 10.5 grams per centimeter cubed? Now, again, question number one. What am I being asked to calculate? The volume of silver. So you draw your triangle with your three letters. Density equals mass over volume. Okay. Now, what am I being asked to get? I'm being asked to get volume. So I scribble out volume. And what am I left with? Mass over density. So what's the mass? The mass is 2,500 grams. See, don't forget, mass is related to weight. So sometimes they might try and fool you that way. They might throw in the word weight instead of mass. They're related. Okay, so we can use the weight in the mass context. Over density, 10.5 grams per centimeter cubed. Now, on your calculator, 2,500 divided by 10.5 comes out as 238.10. What are my units? Well, I'm looking for a volume. Go back to your density. What are the units of volume in your density? Oh, look, centimeters cubed. So that's how you do those two questions when they give you the density and ask you for the mass of the volume. It's all got to do with your density triangle. Okay, now here's what I'm going to do. I'm going to finish here because you have a lot of work to do. I'm going to leave you with a table, and this time the table leaves out maybe a mass, or it might leave out a volume, or it might leave out a density. So in this table here, I want you to fill out the missing volumes or the missing densities or the missing masses by using the triangle. Density is mass over volume, and then you multiply those together. And then say, for example, take this one here. In the first one, you're looking for density. So you cover up density and you get mass over volume. In the second one, we're looking for volume. So you cover up volume and it's mass divided by density. For the third one, we're looking for mass. So you cover up mass and we get density by volume. So by picking the correct formula from the triangle, I want you to fill out the numbers into the missing spaces in each one of those boxes as we move along. And that's not the only thing, because once you've got the table filled out, then here's what I want you to do. I want you to arrange them in order of decreasing density. So therefore, take the 5 substances here and put the one with the greatest density first, and then move your way as you get lesser and lesser and lesser densities down to the one that has the least density. We'll take it up from there tomorrow. Do them in your copies because I'm going to be asking you for the answers, and then we'll take up the finish of this particular chapter the next day.